Hello, I'm Colin Campbell. I've been in this business of diet and health for a long time. And particularly in the more recent years, of course, I've become really quite interested in the whole question concerning the effect of the whole food plant-based diet. In fact, I've become so impressed with this information that we now have, and equally impressed with the fact that many people in the general public really do not know how powerful this effect is. And so I've concerned myself with the question that I want to talk to you today about. Basically, how can we take this information on the whole food plant-based diet idea and really actually advance it to the general public? We need it. The time has come. So let me walk through some ideas here. I'm particularly interested in having this information advanced to the professional research and policy communities as well as the clinical community. I mean, these are the professionals that are involved in this information, and sad to say, at the present time, they are just about as ignorant as some of this as the public is. And this is not going to go forward, in my view, until we understand this little concept called nutrition. I mean, nutrition has really been a very confusing sort of science in a sense, and oftentimes is not recognized even as a science, certainly not in the practice of medicine. But in order to advance this idea about the whole food plant-based diet idea, we really got to take seriously that we know something about this concept called nutrition. Nutrition, by the way, defined generally means it's the biological expression of the food. The diet is a collection of all the foods we eat, and so we eat the foods, and then the biology takes over and digests and absorbs and does all these things with the stuff of foods, the nutrients. That process is what is called nutrition. So I'm going to argue that we need to understand what nutrition really is. Nutrition, as I said, is not very well appreciated in our present system. On the question concerning research funding for nutrition, that would otherwise be supplied by the National Institutes of Health, which is the major biomedical research agency in the Western world, if not, in fact, in the world. There are 28 so-called NIH institutes, and not one is focused on nutrition. So from the research perspective, we get a very, very small amount of funding, relatively speaking, to try to understand this subject. Secondly, in the professional medical schools, nutrition education is basically missing from the curriculum. And that's a very sad commentary, because the people in our society who are going to have to take the lead in this movement, in a sense, in the future, are going to have to be our doctors. And so therefore, their training in medical schools is critical. But we don't do that very well. Now, let's start out with an idea that we start out with in science, namely stated hypothesis. What are we trying to say? My hypothesis for this purpose is nutrition can prevent and actually treat disease more effectively than all the pills and procedures combined. I know that's a mouthful, but that's why I'm going with this story. I started my research career long ago on August 1st, actually, 1956, so it's been 60 years ago since this past August 1st. And I started with a personal bias. I spent most of my career at Coronary University. And as far as that bias is concerned, I was at that time really interested in promoting the consumption and production of more animal protein. That was the deal. I had come from a farm, and I was the first in my family to even go to college. In fact, my father only had a couple of years formal education. And on the farm, milking cows, to the extent that the word nutrition ever even appeared, I can't claim it did, quite frankly, but in any case, to the extent that we were producing milk and selling milk is concerned, we generally knew that it was a good source of protein, so-called animal-based protein. Then I went away to school at Cornell University, graduate school, and my doctoral dissertation actually was on an attempt to try to produce animal protein more effectively, because it was that important. Of all the nutrients we can talk about, animal protein was considered to be the thing at the center of the plate that we had to pay attention to. Then after that, I was spending some time in the Philippines. At that time, I had a professorship at Virginia Tech in Blacksburg, Virginia, and we had a contract with the State Department, U.S. State Department, and with the Department of Health in Manila to set up a nationwide program of feeding malnourished children. And like other poor countries in the world, malnourished children were plentiful sometimes, and most people thought in our profession that what they needed most was protein, more so-called high-quality protein, which means animal-based protein. So we were there. I was involved in that for about 10 years with my senior colleague and others to set up a nationwide program for feeding malnourished children and promoting more protein. We were living with the general concept in those days that there was a protein gap in the world. And that's why some countries, the poor countries, had a problem because their children were not getting enough protein. So again, following my personal life, my graduate school days, and then my early career was all about promoting more animal protein. But then I saw something rather peculiar, and it was, as we say, anecdotal. This was not published. It was just an odd thing that was told to me by my medical colleagues. And at that time also, I should say that I had an interest in how cancer forms and how it progresses. And so I was wearing two hats. One was in regards to cancer, human cancer. The other was in regards to nutrition, which was, as I said, mostly focused on protein. But I saw something I thought really odd. The few families consuming the most protein, the level of protein that we tend to consume in the West, obviously, the few families consuming the most protein, it seemed to me that there was more childhood liver cancer. Well, that's a stark thing and it's not to be believed, but there it was. And then about that same time, with that doubt in our minds, this publication came out in 1968 from India by Mahadevan and Gopalan. And they were interested in that time, and we sort of had a similar interest. They were interested in what causes liver cancer. That was the kind of cancer that was occurring in children, I thought. But their idea was that although cancer starts with a mutation and maybe some chemicals in the environment, one in particular in this case, that it was really the level of protein that might be helpful. And their hypothesis was if they could give animals that are exposed to a carcinogen more protein, they would be less likely to get the cancer. And by more protein, I mean they had one group was 20% of total calories as protein. The other group had only 5%. And so all animals were programmed essentially to get liver cancer. And here's the results they got. The animals given a higher levels of protein, 100% got the tumors or preneoplastic tissue. The animals given a 5%, none. That was pretty stark, 100% to 0% essentially. So between the children observation, anecdotal, together with this experimental animal observation, which was published, it said the same thing. More protein, more cancer. Really a stark idea. Then I came back home and got a grant from the National Institutes of Health and started doing some research with lots of colleagues, especially students and others over the years. And I want to just show you here just a couple of little demonstrations of what we saw that really became so remarkable. Here's a chart, for example, in experimental animals showing that on the x-axis, how much cancer occurs. On the y-axis, on the x-axis, the number of weeks. On the y-axis, the cancer index. And so I'm going to show you what happens in these animals, starting out with a genetic mutation, that's they're exposed to this chemical carcinogen, then two different levels of protein, 5%, you can see those results there. No tumors are forming, no early cancer is forming. 20% doing quite well. So we were seeing the same thing as what the Indian workers had reported. So then we wanted to do a number of different things and see how we might understand the mechanism by which this works a little bit better. And so one of the studies that really caught our attention to this protein effect was the fact that when we tried to, let's say, switch diets from 20% to 5% and back and forth, I wanted to see if it had any effect on the development of cancer. And here you can see at 3 weeks, animals fed the 20% protein, the cancer is growing quite well. You feed them 5%, it turns it off. 20% turns it on, 5% turns it off. And we did this in many, many different ways. This is just, I wanted to demonstrate a point here that in effect, we could turn cancer on and off by nutritional means. Nothing exceptionally unusual about in this case. It was just protein being fed at different levels. We saw this really rather remarkable effect. So that was a surprising result. It was really at odds with what anyone thought at that time about cancer, and unfortunately still today. Most people think cancer is a result of genes or mutations in the environment, foreign chemicals, or maybe viruses and that sort of thing. It turns out that what this is showing here, that regardless of the contribution of those other agents, nutrition is really what controls whether or not cancer occurs. And what's really exciting about this, sort of said it in a different way, but very significant, cancer appeared to be reversible by nutritional means. So then we had another observation. We actually, in these experimental animal studies that went on over a period of about, 12 to 13, 14 years or so, funded by the NIH, it turned out that we actually were deriving from this information a lot of so-called nutrition principles, which began to turn my head as to what nutrition really is. And so I've got 2 things listed here. We just showed those to you. Development cancer can be turned on and off by nutritional means, and cancer development is reversible. And this third one that led to a really large discussion in many different other models, nutrition essentially controls genes. And that's one of the major effects of nutrition. It is in the business of turning on good genes and turning off bad genes. Now I want to just talk a little bit about the so-called mechanism by which this works. I mean, it's difficult enough to sort of even say that high protein might turn on cancer. But in order to get a better feel for that, I wanted to know something about the biochemistry of this business and know the so-called mechanism. Now, for that purpose, in cancer research, those of us who do this kind of research, we tend to divide the whole process arbitrarily up into 3 phases. There's a first phase called initiation. That's when the mutation actually occurs. Chemical comes into the body, goes into the cell, gets metabolized, it binds to the DNA of the genes, and if that's not repaired and that cell divides, then it incorporates that mutation into the second generation cells. It's a mutation. Second stage promotion, that's when the cells are dividing. Eventually, they come to our attention. The cell mass is becoming troublesome, and we get diagnosed, and that's more or less when we talk about progression, when these cancer cells may decide to go to other tissues. So that's the model. They involve different kinds of mechanisms. I wanted to see if we could learn, maybe where's that elusive mechanism that's responsible for this protein effect? Is it first stage, or second stage, or what? So we started looking. What's going on here? In the first stage, and this is a lot of work, I have to tell you, over years, we learned that looking for this mechanism, we found that the high protein diet during initiation does things like it increases the rate at which the carcinogen gets into the cell. Neat, interesting idea. And I said to myself, maybe that's the reason that the high protein turns on cancer. No, it does more than that. Actually, it increases the synthesis of an enzyme responsible for metabolizing that carcinogen. And it does it a couple of different ways. It increases the amount of the enzyme formed. It increases the characteristics of the enzyme and therefore its activity. And it does, as you can see there, it increases the binding of the reactive product of the DNA and so forth and so on. We essentially looked at 4 possible mechanisms for this effect. And it turns out every time we looked for a mechanism, it seemed that we found one. So I still couldn't put my finger on which mechanism is a really key mechanism, because essentially this is sort of in the domain of drug development. Namely, the entire pharmaceutical industry tends to reside on the fact that if we see something we want to control, then we find out what is the mechanism at the cellular level, and then we create a chemical, later called a drug, that might stop that if we want to stop it, or enhance it if we want to enhance it in any event. So we're looking for the mechanism here for this effect. And there's 4 possible mechanisms. Now I'm going to summarize really quickly, just give you a little picture of this. Here's the cell. The carcinogen, the C, is outside. It comes to the inside. And then it gets metabolized by the enzyme called a mixed function oxidase, or MFO. Excuse me. And that produces a product called a carcinogen epoxide. That's very reactive. And it only lasts for microseconds. But it's so reactive that if DNA is nearby, it binds to the DNA, and then if it's stuck to the DNA, it causes a damaged gene. So there's the first initiation stage. I'm going to put some stars on this, what we just summarized a moment ago, to show you the different stages where the protein is having an effect. It's blocking the entry of the carcinogen on the outside to come into the inside. Then once it gets on the inside, it's basically increasing. This is high protein, by the way. The high protein is increasing the amount of enzyme present, so it's kind of speeding up that reaction, going to the epoxide and subsequently to the DNA. So it's increasing the amount of enzyme. Here's another star. It changes the conformation of the enzyme in a way in which the enzyme becomes more active. So same result, essentially. And then fourthly, it actually increases the amount of the carcinogen binding to the DNA that makes it a potential mutation. You know, we looked at all these things. These are really quite sophisticated biochemical experiments that took probably 4 or 5 years just to do this. But we actually demonstrated that the high protein diet was doing all these things. Now there's another, just abbreviating it down a little bit. See, there's 4 stars there, what we're talking about in the cell. After the damaged DNA is there, it turns out that our cells have a marvelous ability to actually repair that damage, because this kind of stuff goes on all the time in our bodies. We get exposed to chemicals that might cause cancer, and it might bind to the DNA. But our body has, as I say, this fantastic ability to basically repair all of it. I'm meaning 99.99% of whatever it is. But occasionally, if the cell divides at the moment, a carcinogen is bound to the DNA, then we've got a new cell generation. Now it's carcinogenic. It's capable of going into our cancer. So there's my little picture showing how this DNA is otherwise repaired in a normal setting. The high protein diet actually blocks that. It's pretty amazing. So the high protein diet is increasing the amounts forming in the first place, and then it's actually corrupting or intercepting the body's mechanism to normally get rid of it. So there's 5 mechanisms. So let's go on beyond that. Now we're into the second stage, promotion. After that, and you can see at promotion stage, we know it's already reversible at this point. So we look to see what's going on in that second stage, and it turns out there was a whole bunch of things going on. When the early cancer comes, and there's a cell there, and mind you, this is only about 1 chance in a million that you might get one of these early cancer cells in a normal setting. The early cancer cells, now they're ready to go. The body yet again has another mechanism to clear that out of our system. It's a part of the immune system. The body goes around and scavenges these nasty little cancer cells by a group of cells called the natural killer cells. By obvious name, the name is obvious. And so the body has a normal ability to clear out these cancer cells and keeps us from getting cancer. So what does protein do on that score? Turns out it blocks that too. So every time we turn around, this high protein diet is blocking the body's normal ability to keep things under control. And then in addition, we looked at some more mechanisms going forward over a period of time. It's usually a long period of time from initiation to to progression. So the promotion period is quite long. We found out things like, it basically affected the energy metabolism in a way that would promote cancer. It turned on a hormone that caused the cells to divide faster. It did a whole bunch of different things. And so now we got a total of 10 mechanisms. So every time we looked essentially for a mechanism, we found one. This is really odd. I mean, I was looking for a single mechanism, like everybody assumes. There's some explanatory mechanism. It finally appeared to me that there is no such thing as a single mechanism. There's a whole bunch of things going on here together, and they're all working together almost in synchrony. So the next question was, what is the protein we're using here? It's casein. Of all things, it's the main protein of cow's milk. Kind of hard for me to digest and accept in a way. I mean, obviously came from the dairy farm and was well aware that casein, the main protein of cow's milk, is something very special, and we need it. Well, it was casein that was increasing the cancer in this model. So then we did things like, let's try soy and wheat, even fed when it's fed at the higher levels. It did not increase this cancer development. So here all of a sudden a new idea comes. Casein is an animal-based protein turning on cancer. 2 plant proteins basically did not do that, and even when fed at the higher levels. So this kind of prompted some thinking in my mind and others, and that was there might be some difference between animal-based proteins and plant-based proteins and doing something nasty or keeping things under control. That being said, it turns out that yes, casein as an animal protein and other animal proteins as well does do quite a number of nasty things. So now I think just if we can accept that for the moment, let's have a look at the question concerning, well, what are we talking about in terms of the amount of protein? And so what I'm going to show you here is a representation of what happens, and we did this with our animals. What happens if we change the amount of protein, let's say from 4% up to 20%, in different groups of animals in each of these cases? All the animals get exposed to the carcinogen. From 4 to 20%, it turns out that from 4%, 6%, 8, and 10% dietary protein, the cancers aren't growing. And so the cancer didn't start growing until we got in excess of the 10%. And it turns out that this representation here that we did in the laboratory for cancer is rather similar to the representation of what protein does for other diseases as well, heart disease, diabetes, and so forth. Up to about 10% of protein or so, everything is kind of fine. So let's have a little closer look at these numbers here. We'll see what it means in the context of our present understanding of how protein relates to health. So before I go into that point here, let me point out that Western countries consuming the high protein diets are consuming diets and protein content from in the neighborhood of 10 to 20% or even higher. So on the right-hand panel, that's the experience of Western countries. It's in a territory where most of us are actually consuming protein levels that might be causing us some problems. So let's now look and see something else that might help us to understand this whole protein issue. Namely, we've known for, close to a century almost, that the minimum amount of protein we actually need, and we do need protein, by the way. We absolutely need protein. The minimum amount we need is around 5, 6, 7% or so. That's the amount of protein required to match the amount of protein normally lost in our urine and feces. So there's a minimum level. But when the minimum level was first discovered many, many years ago in a group of volunteers, if you will, in an experimental setting, the scientists in those days wanted to make sure, well, that's what it is for this sample group of individuals. But what about the larger population? So to be assured that the larger population got enough protein, they added as we say, a couple of standard deviations to that minimum. That brought us up to the recommended dietary allowance, or RDA. That's the RDA's recommended dietary allowance of protein per day. In this case, it's expressed as percent of total energy. But in any case, we have the RDA. And it turns out, if you just look at it just at this point here, I think we can say, therefore, that the RDA is essentially the ideal level of protein. So said before, we need protein. If we didn't have protein, we die. So we need a certain amount of protein. And the level of protein that meets the minimum, yet at the same time avoids disease, in a sense, whether it's heart disease, cancer, or anything else, then we ought to be staying in the territory of around 9, 10, 11% protein, okay? But our diet, remember before when I was talking to you about the idea that plant protein and animal protein appear to be different. I want to kind of jump ahead over a lot of data that I'm not going to discuss here to try to sort out when we talk about total protein, what are we talking about? Animal protein or plant protein? It turns out that, I forgot to mention here, that the average protein content for the average American is around 18%. 17 to 18%. We don't need 9 or 10 or so. We're way up there. Let's talk about it now in the context of the kind of foods that meet our needs. Plant-based foods have all the protein we need. Just whole plant-based foods. They easily supply our 8 to 10% protein. That's not an issue. In fact, if you're eating some high-protein plant foods, like soy maybe, or legumes, especially leafy greens and things like that, you can get up to higher levels, quite frankly, with that, and it's not going to cause a problem. So plants actually provide all the protein we need. We get it to higher levels basically by consuming animal foods. We have for so long, 100 and whatever it is, 60, 75 years since protein was discovered, we've generally assumed that animal-based protein, also called high quality, was essential. And I'm going to suggest for you thinking, it is not essential, but we believe it. Everybody believes it. It's not that we consciously think of it that way. It's just that's not the way it is. But the paradigm within which we live suggests that we ought to have more animal-based protein. So our average is up around 17, 18%. As a matter of fact, the average protein content of the average American diet, the protein that comes from animal sources for the average American diet makes up about 70 to 75%, maybe even more of the total protein. So our average diet is rich in animal foods, and we consume a lot of animal protein. Let me show you another little twist of that story. It's kind of interesting. Let's say in theory, we don't think this way, but let's say subconsciously, let's say we want to get up to around 16, 17% or so. We're adding animal food to get that. We don't need to get it from plants. We think we can't get it from plants. We add animal food. Now we're up around 16% or so. Now we're, in theory, when we get up to 16%, what we're doing, we're displacing some of the calories otherwise provided by plant-based foods. So we can get up to 16% total animal protein, but there we don't get all the plant-based foods. We have to decrease the amount of plant-based foods to get to that level. So there's a double effect here. So let's have a look now at the difference between plant and animal-based foods in terms of their nutrients that they consume. And those nutrients can play a major role in whether or not disease occurs or not. In plants, I've shown here in this chart that they have some antioxidants, complex carbohydrates, and vitamins. In fact, those three nutrient groups are primarily made only in plants. That's the really good stuff. That's what creates health. That's what actually prevents cancer and so forth. Plants also have some fat and protein, but they have reasonable amounts, around 9, 10, 11% or so. Animal-based foods has really none of the antioxidants and complex carbohydrates and vitamins, not the traditional vitamins. So animals are really almost devoid of the things that matter. And when we start consuming more animal food just to get higher levels of protein, we're actually decreasing the amount of plant foods. So therefore, when you look at this picture of diet and health, or diet and cancer in this case, is a combination of the hazardous effects caused by animal protein together with the preventative effects that otherwise are provided by plant-based nutrients. Animal-based foods, by the way, have more fat and protein. So animal-based foods, it's really, from this perspective, it's not good stuff. We're not getting the good nutrients, we're getting too much of the wrong kinds of nutrients. There's also processed foods too. It's another little tricky group. Processed foods can actually be made largely of plant foods. Vegans like that, and I'm not talking about a vegan diet, but vegans basically can have things like donuts or cookies and cakes and so forth and so on, as long as it doesn't contain animal-based foods. But processed foods like that are high in fat and salt and sugar. That's not good. So processed foods are basically almost the same as animal-based foods in a sense, in terms of their effect on health. they are actually coming into the diet and displacing the whole plant-based foods that really make the difference. Okay, so we got three groups of food here: plant, animal, and processed. Animal foods, processed foods, that's not where it's at. Plant-based foods is where it's at. The other two are just mucking up the system, creating some problems of their own, and also causing us to displace the foods we ought to be eating. Now, on this protein thing, one of the things you've seen here so far, I'm just talking about experimental animal data. People will say, well, that doesn't count. Well, it does count when you talk about mechanism, because the mechanisms that occur in mammalians are virtually the same, regardless which species we're using. And that's what matters anyhow. So we got the animal data, high protein, more cancer. Now let's look at here's some human data. This is done many years ago, published in 1975 and republished many times since. The higher fat intake for different countries is associated very impressively with more breast cancer, for example, as well as with colon cancer and heart disease and things like that. All of this has been published. See a nice straight line relationship. More fat, more total fat, more breast cancer. Well, it turns out that was a bit of an over-interpretation of those data in those days, and we got all caught up in over-consuming fat. We should not be over-consuming fat, but we just assumed it was just the fat of animals, saturated fat in particular. In reality, what we saw before really is all attributed to the consumption of animal-based foods, specifically animal protein. So that relationship between fat previously seen, presumably related to breast cancer, is much better described as being a relationship with animal protein. So with that in mind, looking at the nutrition in a holistic sense like that, how much of the different nutrients are doing different things, by the time we got around, and I'm talking about my son Tom, Tom and I got around to writing the book, The China Study, I was particularly interested at that time to see if this effect might relate to more than just cancer. And here's a list of a bunch of diseases for which there is peer-reviewed scientific evidence, much of it really quite conclusive, showing that a whole food plant-based diet actually suspends, that means stopping the disease progression. It prevents, suspends, and or in many cases actually reverses these diseases when you consume a whole food plant-based diet. So the effect is very broad, unlike drugs, which usually deal with one thing at a time. It's also a very rapid effect. We now know that when people go on this kind of diet and then really stick with it and do it the right way, you can see pretty remarkable results within a week or two. It's really indeed very impressive. If the dietary change is sustained, and that's the key, we can't just use this diet as a kind of a drug-like sort of process. We've got to sustain the change and stay there, become accustomed to it, and it really becomes very delicious, of course, during that time. But when it's sustained, then we're talking about not only preventing illness, but also treating illness with no side effects. And so that's why I said in the beginning that a whole food, plant-based diet does more to create health and prevent disease than all the pills and procedures combined. Now, to get a little better picture of that, I want to turn your attention to Dr. Esselstyn, who many of you, I'm sure you know, worked with heart disease and with real people. He and I didn't know each other at the time when he did this, but he basically was feeding them an all plant-based diet, starting out with low-dose statins in the beginning, but later basically concluded that it was a plant-based effect, and actually got results that were really remarkable. The people in this study, there were 18 people in the study with heart disease. They came in with 49 coronary events between them in 8 years prior to getting into the study. And then after 12 years as far as publication is concerned, and 27 years altogether, they went from 49 coronary events to 0 when they're on this kind of diet. Now he's published a second paper in 2014, a much larger number of people, heart disease. He brings them in, counsels them for 5 hours with his wife, Ann, comes back and sort of then 2 to 7 years later calls them up and asks them how they're doing, if they're still doing it. Remind you, they had, as I said, mind you, they had heart disease. Comes back 2 to 7 years later. It turns out of the 196 he started with initially, 177 of those people were still doing as he said. 19 decided not to. So he had a group of 177 that were compliant with his recommendations, 19 who were not. How did they do? Well, first off, that 177 out of 196, that means 89% of the people he talked to in the beginning, they continued to comply. And that's an important point because a lot of people think that, they'll learn this and they're not going to stay with it. Well, these people have heart disease, they're motivated for sure. But he also is very effective in explaining why they should do this. So 89% of the people he spoke with are still doing it between 2 and 7 years later. Turned out, heart disease events for these two groups, the ones who were compliant, less than 1%, only one person actually, had a heart problem. Of the others who were not compliant, they decided not to do this. 67% had heart disease. I mean, that's a huge effect. That's really what I'm talking about is an excellent example of using whole food to create the kind of response that you see here, really dramatic. And there's no drugs that can do anything like that. So the future is, let's go to expand this a little bit to see what we might see in the future. The future is not this, and I want to emphasize this point. We tend to think of food and its effect on disease in terms of individual nutrients. As a result of that faulty thinking, we think we can take nutrients out and put them in a pill, like, vitamin supplements. They don't work. They might look like they work for a little bit in the short run, but in the long run, all the evidence now shows they don't work. So when I talk about nutrition doing its thing, I'm talking about nutrition is present in food, not in nutrient supplements. Now let's talk about that a little bit because I think we're going to have to change our thinking a bit on what nutrition really is. So let's look at the disposition of a single food nutrient in the body, for example. It comes in, we got a whole lot of nutrients consuming and a spoonful of food. We might be able to know how much we have there in that spoonful or that cupful, but does that tell us very much? When the nutrient is being consumed, it goes through all these processes. First, it gets digested. That means the nutrient is being freed of its food connection and released into the intestine. And then that stuff that's released gets absorbed across the intestinal wall and it gets in the blood. Then it's transported. And maybe it can be transported in an active form and maybe an inactive form. And then it goes to the organs and can go all over the body and finally gets into the cells. And there it goes through some metabolism. Some of it gets stored in excretion. I mean, that's a lot of very complicated steps. And even if we were to know how much nutrient is being consumed in the beginning, we have no way of estimating how much nutrient actually gets to the site where it does its business. This is something people tend not to realize. It's a very, very complex system that it passes through. And what's important about this is the body is always adjusting on a nanosecond by nanosecond basis on how much of a given nutrient or its metabolite goes to the next stage. And it might vary by as much as 10, 20, 30%, or 40% for each stage. And you can just add up those percents. There's no way of knowing, even if you knew how much is how much you consumed in a given moment, you have no way of knowing how much is there going to be there where the nutrient really functions. So this raises a new kind of question. We can't decide our nutrition necessarily on exactly how much nutrient we consume. We should get out of that kind of thinking. It's a very reductionist kind of thinking. We got to pay some attention to the idea that nature, the body itself, knows how to handle how much nutrient gets digested, absorbed, transported, and taken to the body, into the cells, and how much is actually metabolized in various and sundry ways. The body has this enormous capacity. That's just a very natural thing of adjusting this all the time. All we need to do with this kind of message here, choose the right food. So the body has the easiest time for working on this. And as long as it has enough of the right food, then it decides on how much is going to go where, how much is going to metabolize, and all the rest of it. And the default position of the body is to create health. It's always to create health. Even when we insult our bodies and do all kinds of crazy things to ourselves, the body is always struggling to create health. Put all those ideas together. And what I'm trying to say is that what we have forgotten is the role that nature plays in creating nutrition for us. One image of that you might imagine is a cell, for example. We have Cells, of course, this is the basic unit of biology, and there's a little schematic of it. Each cell is enormously complex. This is where I spent much of my early career in a sense. I felt like I was crawling around inside of the cell. But each cell has all these different parts to it, and all these reactions that are going on, and so forth and so on. We're trying to understand them. But they're marvelous. The cells are marvelous. It's like a universe. It's a universe, or a big universe looking outwards. These are micro-universes. And so we got a whole lot of cells. In fact, we got 10 to 100 trillion cells in our body. That's a number we can't even contemplate. Forget it. 10 to 100 trillion cells. All there doing their work. A lot of cells, of course, are very specialized. They're doing their special things. They all have basically the same DNA from which they can construct things and proteins and so forth. But they're all sort of doing their own thing. Every cell is operating, and then they begin to work together to produce whatever they choose to do. Of those 10 to 100 trillion cells in our body, each cell is not even visible. It can easily sit on the head of a pin and not see it. And yet we have this enormous number of cells that we can't see, and each one of them is a universe. And each cell is deciding for itself how much it wants. Each cell is deciding on how to metabolize things, whether to store it or whether to send it out or use it for this or use it for that. The body has this innate capacity to do this. And this is a dimension of nutrition that has not been told, in my view, hardly at all. And I'm going to suggest this has got to be the new definition of nutrition. It's not about individual amounts of nutrients being consumed or in food. It's about basically just eating the right food, and the body will take care of the rest. The DNA chain length in this cell alone is 2.5 inches. That a cell you can't even see. How can that be possible? I mean, I just want to put that there just to try to give you some sense of how impressive that world of cells really happens to be. Now, let me just turn your attention to biochemistry a little bit. This looks complicated, but biochemistry has to do with taking a chemical that may have some energy in it, like glucose, the thing at the top of that scheme, glucose 1-phosphate, and then following it and seeing how it goes through a series of reactions all the way down to the so-called Krebs cycle, that cyclic thing. That's a process a lot of people who have taken elementary biochemistry will know. It's even taught in medical schools for the most part. But in any case, there's the process by which a chemical is metabolized, a sequence of reactions. And I spent the early part of my career teaching biochemistry, and in those days, everything was much simpler. We were very excited about learning about these different reactions and the enzymes that are involved in each reaction. And we thought we were learning a lot of great things. And I taught this, I say, to students and memorized these things and so forth and so on. And then as the years sort of passed in our laboratories, there was always somebody coming up with a new reaction, always something new. And there was a company that used to make these kind of charts. And we all in the laboratory business would get the latest chart, hang it on a wall to see, watching these charts expand and learning new things. And when something new came out, a new enzyme, maybe it made news sometimes. It's a cure for heart disease or some silly thing like that, really critical. Kept learning about these reactions one after another, and finally we got to this. And that reaction, look at that. Isn't that a mess? That's only a small part of all the reactions going on inside of the cell. It may be one thousandth of the reactions going on inside of the cell. So all of a sudden, for me at least, I became aware this cell is a marvelous world. And it's got all this stuff going on. How can I or anybody else sit back and pick out just one of those reactions and then pick it out and say, oh, that's a bad reaction. That's the mechanism. Now I'm going to get some chemical to stop it or speed it up or whatever I want to do and expect to have no consequences. And so quite frankly, it's a kind of a ridiculous idea, but that's the basis for the entire pharmaceutical industry as opposed to nutrition. Nutrition manages all this. Pharmaceuticals come along and they say, we in our bright minds, we think we're going to pick out one reaction and we're going to stop that reaction. We might stop cancer. We might stop cholesterol synthesis and so forth and so on by creating a drug. When we do that, every time we do that, we have side effects. We cannot possibly imagine putting in a single chemical into that system without having side effects. So we're going to finish then on this note here. Nutrition is not what we think it is. It is not just a bunch of reactions, individual nutrients, and all that sort of thing. They don't work that way. And so I have invented this new word called holistic nutrition. I say invented. I'm being a little bit loose with that. The word holistic with the H has been around for a long, long time. As you've seen in dictionaries, people use that word all over the place, and they know it. But I really want to put the W in there because it has a little different cast of meaning, if you will, than just with the H. With the W, we're talking about everything working together. Multiple nutrients, multiple mechanisms, multiple disease reversals, multiple health improvements, all provided by a whole food plant-based diet. And that's why the whole food plant-based diet is so powerful. We got to think of it differently. We can't think of it, it's got this much of nutrient, this much of vitamin C, and that much of this and much of that. Forget it. I mean, those are really kind of trivial things. We got to think of it collectively. It's a highly interactive, integrated, holistic system. And on top of it, I should say, without making protein, I'm talking about animal protein, without making protein a religion. Just keep those two ideas in mind. We're a complex system. It works beautifully. That's nature. But don't get our heads in the way and saying in order to have good health, we've got to consume animal protein, because when we do, we're compromising all kinds of things. We have the bad effects of the protein itself. We have also bad effects caused by the displacement of the good foods. So let me finish here just then on a couple of notes. This idea is an old idea. I thought, I'm very excited about it, and most people seem not to have forgotten there, but it has a history. It's really fascinating. And so I've gotten involved in writing some papers I'm going to be coming out with soon. One having to do with the past, one with the present, one with the future. But on the past, let me just share with you this thought here. Aristotle, 2,000 years ago, I guess, or so, made this statement. At least he's credited for saying this. The whole is greater than the sum of its parts. And that's exactly what I'm talking about. When we use nutrition the way they're supposed to be, the whole is greater than the sum of its parts. Here's another statement, a bigger one even. Hippocrates said, let food be thy medicine, and medicine be thy food. I think the holistic idea of nutrition and health, all we're doing is rediscovering Hippocrates. And isn't it odd how in medicine, all newly minted doctors are blessed and they're taking the oath of Hippocrates? In other words, we're using his name because of his fame. We're using his name, but we forgot his idea, because he's talking about using food, not drugs. Okay, so now we've gotten, I think this information is really very exciting, and the past tells us a lot. It really tells us a lot, and of course that tells us something about the present, tells us something about the future. And I've got some papers on these coming up that I'm very excited about. And finally we get to asking ourselves the question, what about the future? Where are we going to go with this? Well, some ideas here. We've got an online course that's Plant-Based Nutrition. It's our nonprofit organization working with Cornell that does the online courses for the university. And we're offering 30 Category 1 CME credits and its equivalency. And so for those of you who may have an interest in that, you can sign up at nutritionstudies.org. But let me add for you another thought. This is a series in plant-based, PlantPure, the PlantPure Nation series. And that concept, this is the education. This is the education, what I've just talked about. That concept of PlantPure Nation, in my view, is an extremely important dimension to this whole story, because it's, in my estimation, it's the application, it's the extension of the education. Education is one thing. Science is one thing. Education is one thing. Of course, it's essential. But it doesn't mean much unless we figure out some way to go out and actually tell the public how to do it. PlantPure Nation's got a fantastic idea, I think, to develop this national network of so-called pods, and working with other organizations too, together with food that's tasty and effective, and doing the things that I said before, really creating change in a short period of time. So PlantPure Nation, of which I'm proud to say this is part of it, actually is the extension arm of the education. And we got a third arm. The third arm, and it's actually my other son, PlantPure Nation is my older son, Nelson, of course. PlantPure Nation, or I'm sorry, the co-author of our China study, actually Tom, now is a physician at the University of Rochester. He is actually furnishing a program in research. So it's interesting. We've got three legs of the stool: education, extension, and research. You know what? That is exactly the three-legged stool that was the foundation of all the land-grant colleges in the United States, one for each state, for the last 150 years. So this story is part of a bigger story. I think it's very exciting. This nutrition, this education is. Let's not forget, we've got extension, PlantPure Nation, and also research too. The three together has got to form the revolution of the future. Thank you.